Okay, so in this video we're going to sort of bring everything together and look at a real equipment template with its required points that might be used for application validation against Haystack data. And the feature that's going to bring this all together is a feature we call constrained queries. So for this video, I put together a pretty simple equipment template, which I call my AHU. And my AHU subtypes from AHU, so it's got to have the equip tag and the AHU tag. And then what I've done here is I've added children to the points query slot. Okay, so points, once again, if you go back and watch the query video, points is a relationship that defines all of the points that are contained by this AHU. And when I add additional types in here, we're basically saying that in order for this template to fit a given piece of equipment, first of all, I have to have the equip tag and I have to have the AHU tag, but my points query has to evaluate to exactly one of each of these required points. And here I've got the little question mark here, which basically means I have to evaluate to exactly 0 or 1. So in the case of these required points, if I don't find any matching points that fit that particular type, then that's an error. Likewise, if I find multiple matches, that's also an error. And then in the case in this last one here with the question mark, I have to have 0 or 1. If I have multiple matches, that's also considered an error. So this is what a equipment template looks like with required points. And once again, the feature it's using here is what we call constrained queries, where we add additional types in the query and say that when you evaluate that query, you have to have exact matches for those types. So before we look at how this works, I want to show you one more function, which is called lint find all fits. So let's load some data. I've got a very simple trio file here that has some data. So you can see I got 3 AHUs. There's nothing here. They got the AHU tag, the equipment tag, just 1, 2, 3. I haven't even given them display names. And then let's look at our points. So you can see here that AHU1 has no points contained, so it doesn't have any containing points. AH2 has a discharge temperature here and a discharge airflow here, okay, but no fan points. And then AHU3 has neither the discharge air temperature or the fan, but it does have, it's missing the temp and the flow, but it does have multiple hits for the fan run command, okay? So the feature first I want to show you is this function called lint find all fits. Okay. Now this is an interesting function because it takes a set of entities in your virtual database, could be equipment points or whatever, and it finds all the potential matching types. So we can see here that in my standard Project Haystack points that I am matching discharge fan run command to those 2 points, and airflow and temperature to those temperature and airflow points respectively. Now, this is a useful function because one of the things you may want to do when you first evaluating your database is, do all my points actually map to a template in my library? Or do they match to multiple templates? So we can run this function on our data to find all the reasons or all the matching types for a given entity record. And likewise, and then if you're confused why a particular type is not matched, then of course we can use the lint fits function that we looked at in other videos. So let's go back and look at lint fits from the constrained query perspective. So the first thing I'm going to read is at AHU1. Okay, and if you remember, he's got no points. He's got no contained points. So let's run him and see, does he fit my AHU? He does not because he's missing those required points. So now let's do a lint fits and ask why he doesn't fit. Okay, well, there we go. He's got 2 problems. One is he's missing the required point discharge air temperature sensor, and he's missing the required point discharge airflow sensor. Okay, so it's telling you exactly why that particular record is not fitting this type, my AHU. So let's look at AHU2. Okay, and we can see he did contain 2 points. He contained a temperature point and a flow point. So let's see if he fits my AHU. He does. So I got 0 lint errors, and if I was to run just the simple fits, that's going to return true. Okay, lastly, let's take a look at AHU3, and if you remember this guy, he has neither a temperature or a flow point, and he's got multiple fan points. If you remember the previous 2 things we looked at, fan was optional, so that was not considered an error. So let's go ahead and lint him. Does he fit my AHU? That's going to be false, as we would expect, and let's ask why he doesn't fit. And we can see we've got 3 errors here. So just like the first AHU, he's missing the required points for discharge air temperature sensor and discharge air flow sensor. Now, this error is new. We had multiple hits for the fan run command. If you remember, that was optional. So it's allowed to have 0 hits or 1 hit. But if you have multiple hits, then that's also an error, okay? Because we actually have multiple potential points that match that particular point type. And that would happen also with the required points. Those are basically exactly 1. 2 or more is also considered an error. So hopefully that gives you a feel for how the constrained queries can be used to build up fairly sophisticated templates. You use the query to create whatever relationships you may want to check in your graph of data, and then you add these constraints that says, oh, and by the way, I expect these specific types to exist within those relationships. And of course, the 95% case here that we expect people are going to use this feature for is equipment templates by creating equipment types that have these constraints on their required points. So anyways, that's all for this video.